Today I'll be talking you through my submission for the major project component for plan and implement surveying projects as part of the advanced diploma course at RMIT 2018. The assessment was designed to demonstrate the ability to manage a project through to completion, and this project was a feature and level survey that also included a 3D scan of the property. The property itself is a residential dwelling where the client is the homeowner. They're chasing more space and they want to know their options on making improvements. They've engaged the company to have this work done, and we've agreed on a time frame for completion and the deliverables, which are a CAD drawing of the features and levels of the property and surrounds, as well as 3D modeled imagery that their architect can use to help in the design process. It was completed by one person both in the field and the office, and the quote obviously reflects the expected amount of time and effort involved, mainly due to the scan and modeling. Before any field work is conducted, there is a bit of a cost analysis to help calculate the budget for the company. Plus, any pre-survey work is completed where documents such as the title, previous surveys, or any relevant permanent marker information is obtained and printed off. Also, at this stage, any dial before you dig reports are requested, as they can come in handy at a later stage. Field work starts with making sure you have adequate equipment for the job. This specific survey was completed using a Leica TS60 robotic total station and Faro 3D scanner. When arriving at the job, it was important to identify any existing marks from a previous survey that can tie the job onto datum. In this case, the previous survey was on MGA and elevations on AHD. With the marks identified, the total station was set up on one known mark and the datum bearing set to a second known mark. Further checks were then carried out to confirm the job was on datum, and this meant radiating to any other known marks and also checking offsets to fencing. A field card was then completed as a quality assurance check. With the job on datum, the features can now be recorded. These include spot levels, significant trees, footpaths, driveways, ridge heights, building footprints, fencing, floor levels, and anything outlined in the job briefing. Photos can then be taken for future reference when drafting. The job file is then exported from the machine and reduced using Trimble TerraModel software. Other resources such as Nearmap can be used to assist in the drafting process. The draft is then cleaned up where the features are put into their specific code tables and given a specific color. Here you can see the levels and the features for the property and surrounds. The final plan is fully annotated, added to a company template with the correct scale for the chosen plot size. The template will also show additional details such as the orientation, permanent marker information, volume and folio details, as well as when the survey was completed. Some observations made after this survey were the speed it takes to do a feature survey as a solo party, but also the safety of the equipment when setting up the instrument or the targets in high traffic areas. Another was familiarity of equipment, knowing how to set up the machine and set up the job. In this instance, the job codes were not brought over from the machine, so a lot of manual work was required when drafting. Aside from the physical scanning process, internal measurements were taken to help with the modeling. The scan data was then registered using Trimble RealWorks, where at this stage quality assurance checks could be completed to make sure the accuracy was acceptable. The data was then limited to a point cloud where the specific area was required and exported into AutoCAD Revit. By creating layers of differing elevations as well as horizontal grid lines, the Revit modeling aspect could then start to take place. Creating elevations allows you to set a base and a top limitation, and the grid lines make it easier to select points when adding elements to the model, such as walls and ceilings. With almost every attribute being customizable, this part of the process could be as detailed as you want.